Solving systems of equations by graphing and substitution. Here's the first one. You need to solve this by graphing. And if you must solve this by graphing, the first thing you must do to graph an equation is to make sure it's in slope-intercept form. This is from the 9th grade. And that is y equals mx plus b. So the first equation, to get y by itself, you move the 2x to the right side and you're left with negative y on the left. Negative 2x on the right and keep the plus 1. You may not have a negative y on the left. Divide everything by negative 1 to get y equals 2x minus 1. Now go graph it. The y-intercept is negative 1. So go find negative 1 on the graph. Make a dot. The slope is a positive 2. So from that dot, you're going to go up 2 and then over 1. Up 2 over 1. All the way through. And then graph that line. Okay, so I'm going to graph this in red and black. And move it over so that it's right on it. There is the graph of y equals 2x minus 1. Now you have to go through and do the same thing for the second equation. So for the second equation, we'll switch to blue, and we're going to come down here. We want the y by itself. Keep the 3y on the left, move the x to the right, make it negative x, and keep the plus 4. To get y entirely by itself, you must divide everything by 3. So y equals a negative 1/3 x plus 4 over 3. 4 over 3 is the same thing as 1 1/3. You need to know that so you can go find the y-intercept. 1 1/3 is what we're looking for now. So we'll zoom in here. 1 1/3. 1 1/3 would be approximately there. And from that, we have to follow the slope. The slope is a negative 1/3. So we have to go down 1 and to the right 3. If I went down 1 from that blue dot, it would put me here. But then I have to go to the right 3. 1, 2, and then 3. Now draw the line. I'll do this one in red as well. Well, maybe we can try blue. Okay, we'll try blue. And it's going to be close. Almost hit it exactly. There we go. The solution to this system of equations is the intersection point of the two lines. The point consists of two numbers, an x and a y value. First of all, I'll tell you ahead of time that all of these are designed to come out to be integer answers, such as negative 1, 2, 5, 3, so forth and so on, so that you do not have to guess about anything that might intersect here. If you had two lines intersecting there, it would be kind of difficult to tell exactly what those numbers were. So given that fact, what point do these two lines intersect at? 1, 1, right. 1, comma, 1. Points are listed as x, y. Therefore, from this we can assume that x equals 1, y equals 1. If you want to make certain you have the right answer, then plug that in, 1, 1, into one of those equations. plug it into the original one. We'll try 2x minus y equals 1 first. 2x minus y equals 1. Plug in 1 for the x and 1 for the y. 2 minus 1 equals 1. That boils down to 1 equals 1. That is true. So it works out. Sometimes it may work for one and not another. If that's the case, it's not a solution. Look at the other equation. X plus 3y equals 4. X plus 3y equals 4. Plug in 1 for x and 1 for y. 1 plus 3 equals 4. 4 equals 4, so it does work out for both. Therefore, 1, 1 is the solution to that system. Let's put the first equation into slope-intercept form. So this one, we're going to leave the 6y where it's at, move the negative 4x over, change the sign, and keep the plus 4. From there, we're going to divide everything by 6 and simplify where necessary. 4 over 6 is 2/3, and 4 over 6 again is 2/3. Let's go ahead and change the other one while we're at it. Let's move down to here, and that's going to be a negative 3y equals negative 2x minus 2. And then from there we will divide everything by a negative 3. Simplify where necessary. Double negative is positive. Double negative is positive. So in this case we end up with this and this. Are they the same equation? Is there any need to graph this? No. The solution is infinitely many solutions. The first thing we need to do is to rearrange the first equation into slope-intercept form. That means get the y by itself. So leave negative y on the left, move the negative x to the right, change the sign, and leave the minus 1 on the right. Divide everything by negative 1 to get negative x plus 1. We must graph that. Negative x plus 1. So we need a plus 1 on the y-axis, and the slope is going to be negative 1, which means you go down 1 over 1. Now draw the line. Here comes the line in red. Whoops, that's not what I wanted to put on there. I need the line tool. See if I can take that out. Yes. Okay. See how close we can get this. Looks like it's right on it. Okay, arrows, and there's the first line. Now we'll go back over here and rearrange the second equation, and that's 2x plus y equals 0. We have to leave the y where it's at, move the 2x to the right, and there's no need for the 0. The y-intercept is 0, so we have to go to 0, make a dot, and the slope is negative 2. So from that we have to go down 2 to the right 1, down 2 to the right 1. Alright, let's draw this one, and this will be in blue. Okay, not looking too good there. I guess this might be it. Okay, I think we've got it. Where do these two lines intersect? Negative 1, 2. We know they have to be integers because that's been given to you. So negative 1, 2, but let's check to see if that is the right answer. So we will go back over here and put in negative 1, 2 into the first equation. That would be negative 1 minus 2 equals negative 1. That's 1 minus 2. And that turns out to be negative 1 equals negative 1. So that one works out. For the other one, 2x plus y equals 0. 2x plus y equals 0. Let's put in a negative 1 and then a 2. So negative 2 plus 2 comes out to be 0. So that one works out as well. The answer is indeed negative 1, 2. If you have two lines that do not intersect, they can be described as being inconsistent. If you have two lines that do intersect like this, they are consistent. If you have two lines that end up being the exact same line, one over top the other, then they have an infinite number of points in which could be the solution for the problem, because they constantly intersect each other. They're the same line. So in this case, they have infinitely many solutions. We must solve this system of equations by substitution, not by graphing, and show the work for such. In order to solve by substitution, you must solve one of these equations for a specific variable. We did this earlier on and had it on a test, where you're given a formula and you isolate a specific variable. You can pick whichever one you want. Pick one that might look like it's a little easier than the other to mess with. I'm going to try the first one, and I'm going to choose, just because I want to, y. I'm going to put y by itself in the first equation. I chose the first equation for no other reason than I wanted to. And I chose to isolate y for no other reason than I just wanted to. So here it is. The equation is 4x plus 2y equals 16, and I want the y by itself. So I'll move the 4x to the right, change the sign, and then divide everything by positive 2. When I do that, I get y equals, yes, this is a negative 2x and then plus 8. We're going to sub that in for y in the other equation there. And that is 5x minus 3 times, instead of y, we are going to put a negative 2x plus 8. And all of that is equal to 9. We solved for y and came up with this. And we're plugging negative 2x plus 8 into y in the other equation. Here's where y should have been, and here's where we dump this into there. Once we do that, we have just one variable to solve for now. So simplify where you can. 5x minus 3 times this quantity is really plus 6x minus 24 when you distribute the negative 3. Add the x's together to get 11x from this. You can move the minus 24 to the right side. Minus 24 to the right side is going to be plus 24. So 11x equals 33. And divide the 33 by 11 to come up with 3. If If you turn in 3 for an answer, it will be wrong because there are 2 answers for a system of equations. So you have to go back and solve for y. We know that we solved for x and came up with a 3. So go back to your original set and choose either one of those. I am going to choose 4x plus 2y equals 16. And come over here. 4x plus 2y equals 16. And we know that x equals 3. So I put 3 in for x. 4 times 3 is 12. And I will move that 12 to the right side. 16 minus 12 is 4. 4 divided by 2 is going to be 2. Put the answers together. We found x to be 3 and y to be 2. 3, 2 is the answer. All right, solving by substitution. I think I'm going to choose the second one and get the y by itself. When I do that, the 0 is just gone. And if I divide negative 4 by 2, I get a negative 2. So y equals negative 2x. I can put negative 2x in for y in the top equation. So negative 6x plus 2 times a negative 2x equals 10. And solve this one. So that's a negative 6x plus 2, or not 2, actually that's going to be a minus 4x. Let's see if I can clean that up a little bit. Yeah, there we go. So negative 6x minus 4x equals 10. That's a negative 10x equals 10. Divide 10 by negative 10 to get x equals negative 1. So negative 1 has got to go back in to one of those equations. I am going to choose the second one again, 4x plus 2y. So 4x plus 2y equals 0, and I just solved for negative 1 for x. That'll give me a negative 4 plus 2y equals 0. 2y equals 4. And divide the 4 by 2 to come up with 2. Before you come up, the answer should be expressed as negative 1, 2.